So picking up from where we left off, we're now going to do this mathematically. That is to say, we're actually going to use maths to calculate resultant vectors and the angles that they're at as well, rather than actually measuring them using a ruler and protractor. So we're only going to consider cases where the vectors are at right angles. That makes the math simple. It means we can use Pythagoras' theorem, as we're going to talk about in a moment, and it is all we need to worry about at this level. So we're going to start off by looking at displacements. So now this is 4 meters and 3 meters, and we're going to label this. So this is O, and this could be maybe A, and this can be B as before. So now we've been given these two displacements, and now we're going to find the resultant OB, just as we did earlier. But now we simply are going to draw, so we've lined these vectors up, because this is B is a physical place, O is a physical place, and we're simply going to draw this line. That's our resultant. And we're going to find the magnitude of that resultant, which is OB. So we're going to find the magnitude of OB, and we're going to find its angle to A, or to north, we could say. Often you will just be asked to give the angle to a reference line, and in this case we're going to use OA. So this is our angle theta. We're going to use Pythagoras' theorem, which is that the length of the hypotenuse, which is this side, OB, is simply equal to the square root of the square of OA and OB added together. So that is to say that OB squared equals OA squared plus AB squared, which is to say OAB squared is 4 squared plus 3 squared, which is 25, which is 5 squared. So OB is 5, that is to say the magnitude of OB, which we'll work like that, is 5 meters. And then to find theta, we simply use the fact that tan theta is the opposite over the adjacent, which is 3/4. And so we would simply find theta equals inverse tan of 3/4, which we find to be about 36.9 degrees, just by putting that into a calculator to 3 significant figures. So that's what theta is there. And that's how we've done it. We found the resultant, that length, the magnitude of that displacement is 5 meters, and the angle between the two is 36.9 degrees. Very straightforward. And now we'll simply do this with forces. So now it's a bit more complicated. So this is a free body force diagram. We have some particle P. We have two forces acting on it. We have this F1 here.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.